Algebra 1 Common Core, Unit 8, Section 3, the quadratic formula. So the quadratic formula is a pretty important formula for us, and it's actually given to you if you're a New York State student taking the New York Regents exam. It's given to you on your State Regents reference sheet, and here it is, the quadratic formula. After you use it a couple of times, you probably end up having it memorized anyways. But what exactly does the quadratic formula do for us? Well, the quadratic formula is another method to solve for the roots of something. If I go back to the notes from video 8.1, remember what we were doing here is we were factoring and solving, and when we factored a quadratic, when we set it equal to 0 and factored it and solved it, we got, in this example, 4 and negative 2, and those were the roots, the zeros of the quadratic. So you can factor to find the roots of a quadratic, but the problem is that what if your roots are decimals or possibly irrational or even imaginary, which is something you'll learn about actually in Algebra 2. But the issue is the roots, like we saw in this example here, were nice and simple, negative 2 and 4. And all these examples, like negative 6, negative 2, 7 and negative 3, negative 4, 4, 0, negative 7. Like they were nice, simple integers. Well, it's not always like that. And when they're decimals or even irrational decimals, it's not factorable. So what you're going to see here in these quadratics is something that's not even factorable. And it's difficult to see that. Like looking at this, how do I know I can't factor that? Well, it's kind of hard to know you can't factor that, especially when there's a number in front of x squared. Like, could it be AC factoring? And you could try it, but you'll run into a problem. You won't be able to complete the process and get what you're looking for. So there are times where things are not factorable. And one of the hints usually is in the direction things will say like, solve the quadratic in, simplest radical form, because we're going to have to deal with radicals here. Or if it wants the roots rounded to the nearest hundredth or something like that. If it ever asks for the roots as a radical, simplest form or rounded, that probably means that they're decimal roots that you can't factor to get. And so the quadratic formula basically is our way to find roots when we can't factor. Now you can use this for factorable roots also, but usually factoring is a lot quicker, a lot cleaner. So we typically only use the quadratic formula when we have non-factorable quadratics. For example, this. Now the way the quadratic works, it starts with x equals, because remember your roots are x equals, like we again, to keep going back to the previous page here. Like so, the answers were x equals 4, x equals negative 2, x equals negative 6. So your roots we write as x equals because they have x values, because we know the y values are 0. So that's why it's x equals in front. And then it's this monster of an equation here. It's probably the ugliest equation you've ever seen to this point. And you get a bunch of letters. We see an A, there's A in 2 spots, there's B in 2 spots, there's C in only 1 spot. But there's letters A, B, and C. And remember where that comes from is your quadratic is ax squared plus bx plus c. So in an example like this, we can see that A equals 2. Now it's not 2x squared, it's just the 2, which is nice. You don't plug any x's or exponents, it's just plugging in numbers. Numbers only. So numbers only plugged in here. And so A is 2. B is negative 6, right, the middle number, and C, the constant, is 3. So it's just the 3 numbers. If you don't see a number, it might be a 1 or a negative 1, right, because we don't always write those. And then you just plug them in the right places. So we start off with a negative B, and so it's negative B. B is negative 6, so it's negative 6. And what you end up happening there is you end up kind of with like an opposite sign of B. So whatever B is, you'll see the opposite sign, and that goes in the front of a plus minus symbol. The plus minus symbol has to do with the fact that we get 2 roots. If you look at back at all that stuff we factored, we ended up with 2 answers. Most of the time your parabolas cross your axis in 2 different spots. So we need to be able to get 2 answers from this single formula. And the way we do is, in the end, we end up splitting it up into one with the plus and one with the minus. So we keep it plus or minus while we're working on it, but in the end, we could separate them to be 2 different roots. And so that's what's in front of a radical, a square root. Inside the square root, this piece in here, it's actually called the discriminant. And you'll learn more about that in Algebra 2. but the b squared minus 4ac. That's typically where students make their mistakes here. But again, check out the substitution, what I did. So b squared is negative 6 squared. And then minus 4 times a times c. So I replaced b with b and a with a and c with c. So all three numbers go in here in some place or another. The most important thing is remembering that b is squared. And it's important to put that in parentheses before you square it, because a negative number squares to positive. And that's a common mistake, is people think that that'll be negative 36, and that's why they'll end up getting the question wrong. But that negative 6 squared actually gives you positive 36. And then you have a negative 4 times 2 times 3, that gives you negative 24. 36 minus 24 is 12. Now what I'm going to show you is I recommend typing your entire discriminant into your calculator as you see it. You know, parentheses, negative 6 squared minus 4, parentheses 2, parentheses 3, and hit enter, and it's going to tell you it equals 12. So then you know to put a 12 in the radical. So I'll show you that. And then once you get down to a single number in the radical, you have to simplify the radical. And, you know, simplifying radicals is its own lesson really, but for something like rad 12, for example, you think of two numbers that multiply to it. One of them is square. 4 times 3. 4 is your square. And the square root of 4 is 2. So 2 rad 3. If this simplifying radicals is something that you're confused on right now, I recommend you look that up separately. There's a video for it much earlier in the year, and there's plenty of stuff online that can help you learn how to simplify radicals, because that's something you need to know here, but it's just a small piece of the problem here. So this came out, rad 12 became 2 rad 3. Then the very last thing we could do is we could look to see if we could simplify. Now we had 2a on the bottom. That was 2 times 2. That's where the 4 comes from. You could see if you could simplify these things. An old teacher friend of mine used to tell me to draw a heart around it. Not around the radical, but just around the numbers in front of the radical and the bottom. These three numbers. If they can all be divided by the same thing, you do it. So see how I have 6, 2, 4, I can divide them all by 2. And so divide by 2 becomes a 3, divide by 2 becomes a 1, divide by 2 becomes a 2. But if you can't divide all three by the same thing, then you can't do it. Like you can't do just part of it. You know, my teacher friend used to say, don't break my heart, because he would draw a line, you know, that kind of thing. Pretty silly, but it helps you remember it. So then you get down to simplest form. And that's usually where you stop. You could split it up into one with plus, one with minus, but usually it's okay to leave it together as a single plus minus. All right, so let me do an example for you, start to finish. So the quadratic formula, again, you need to know it, but it's given to you. I'll write it down again. X equals negative b plus minus square root b squared minus 4ac all over 2a. Now when we say all over, don't put the x equals over 2a. Just the stuff to the right of the equal sign is over 2a. And here we have an a value of 2, a b value of negative 4, and a c value of negative 1. So plug them in the right places. So the substitution is going to look like this. So x equals negative b is negative 4 plus minus the square root of negative 4 squared, right? Because negative b, so negative of negative 4, it's going to end up as a positive 4, plus or minus b squared. So b is the first two things you kind of work with. B goes in those two spots. Minus 4, 4 is always there. That has nothing to do with those. That's just in the formula. There's a 4 and a 2 in the formula. And then in parentheses you put a, and then in another parentheses you put c. And in the bottom it's 2 parentheses a. So again, we have another 2 times 2 here. So what is this simplified down to be? Well, I simplify this in kind of 3 steps. First of all, negative b I'll write as what it actually is. So negative and negative 4 is that. Plus or minus square root over, and on the bottom 2 times 2 is 4. So the challenge really is, what is this number here? And that comes from this whole mess there. So again, I'm going to show you, I recommend you use your calculator for this piece and type it in as you see it. Again, Desmos is a nice program for calculator stuff. You'll see me, I'm going to use the scientific version of Desmos here. And let's see, I'm going to type it in the way I saw it. So parentheses, negative 4 squared minus 4 parentheses, A was what? A was 2 and C was negative 1. So parentheses 2, oops, hold on. Parentheses 2, close parentheses, open parentheses, negative 1, close parentheses. And that's how you would want to type it into your TI-84 calculator. And then you have to hit enter and it will tell you 24. This program kind of does it along the way. And so negative b squared minus 4 times a times c comes out to be 24. So right there, I know the number in here, I just didn't want to erase all that. Let me get that back. And that is, keep it in green, 24. All right, so that whole discriminant comes out to be 24. And so that's what's probably going to take a little bit of practice. It's the substitution and getting it to be like that. Then what do? Well, then we need to simplify this. Simplify the radical here. And so rad 24, maybe you need to do that off to the side. I usually kind of write numbers right above it. What multiplies to 24? Again, I need a square number like 4. 4 times 6. And the square root of that is going to be 2. So this is going to simplify down to, I still have the 4 plus minus 2 rad 6 over 4. Simplify rad 24 to be 2 rad 6. Then you could draw your heart around it to see if you can forget about the rad number. The other numbers, can I divide all of them by something? In this case, yes, we could divide them all by 2 again. So this will simplify down to, in simplest form, dividing by 2, I get 2 plus or minus. You could write the 1 if you want, like 1 rad 6, but you could just write rad 6. So divide by 2, over, divide by 2, and that's the answer. And that's how I solve a quadratic. Now, if you were to type this into your calculator, you'd get some decimals. Like if you were to look at your parabola to see, where it's crossing the roots, it's not going to be crossing at integers. It's going to be crossing at decimals. And you could use your calculator to find those decimals. Well, this equals those decimals. Like if you type in 2 plus rad 16, that divided by 2. Or 2 minus rad 16 divided by 2. That's going to account for your 2 roots that you have. All right, so that's it. That's how we do the quadratic formula. It's going to take some practice. All right, see ya.